So we'll hear about the Kubernetes as a service platform from Jan Schone and Yannis Kemper. Please welcome them on stage.
Thanks, good. Yeah, thank you very much. I'm short introduction. I'm Jan, product owner for container technologies in the SCS project. This is Yannis Kemper. He will take say something about the second part because this is our current reference implementation of Kubernetes. So this is everything about KaaS for our Dutch colleague. This has nothing to do with cheese. This is our solution of how we provide Kubernetes. As also the EIS team already did quite a short forecast of our architecture, how it looks like, and of course in this talk it's only about this part. To the turtles we will see a bit more later. But first, because I wanted to talk about the history, I want to cover the tenders first. We had 3 tenders directly in the container team, which is the VPO5, which is probably the biggest one to develop the KaaS integration. Then VPO6A, developing the container network and storage integration. And VPO6C is the container registry and scanning. By the way, all participants of these tenders here are registered for the table tennis tournament.
You're my favorite team.
Okay, I will cover them from bottom to up because it fits a bit better to the second part, so I decided to do it that way. We have the container registry. That is the tender that was awarded in beginning of 2023 to D-Nation. We started with 2 people there, but to be honest, it turns out it was, the people are very good in what they're doing, and I think that wasn't really hard work for them to establish and investigate the different container registry solutions, and then it turned out I think most of them expected it. We use Harbor for that. This is also provided as our current container registry. You can use it. It's on registry.scs.community. You can, whatever, you can also use it as Docker cache if you want to avoid the limits there. But yeah, this is also available on our GitHub repository, Kate's Harbor, and there you can see how we solve our registry. The second one is the container network and storage integration, where most things were almost done upstream, so also nothing to do there. Yay, no, that's absolutely not true. We had many things to do, not exactly on the container layer, but to work good together with the IIS layer, which is OpenStack in our case, obviously. And that's especially about the Cinder CSI, and in our case, the Gateway API. The Gateway API is a kind of new feature from I don't know which zig it is. It's something from the Kubernetes project, and the goal is more or less to be the successor of Ingress. Not that wide adopted, I think, but we try to solve it using the CNI we used, which is Cilium in our case, and also to get Cilium to run, we had something to do on the IIS layer. So there was quite a lot or more work than we expected, and also we are working on standardizing some storage classes, which is still running, which is a bit harder. And also the investigation of, for example, useful network policies, which is, again, quite tricky because the different CNI solutions have different ways to fulfill these network policies. And yeah, this is something like this is ongoing in this tender and also together with the 6 standardization. And then we have also a reference implementation as we use on the IIS stack layer. We needed to find a technology for the KaaS layer. I mean, obviously it's a bit funny now because KaaS already says what it is. Instead of IIS, there we choose OpenStack. In KaaS, it's obviously Kubernetes. But there are different ways to run Kubernetes and deploy and manage it. And in SCS, we decided for the cluster API. And without writing my own text, I just make a screenshot from the first sentence of the cluster API. There you can see that this provides declarative APIs for tooling and simplifying provisioning and upgrading operating multiple Kubernetes clusters, which perfectly fits in the SCS project. And we needed to build something around that. And we started, and that was many months before I started at SCS, with a so-called KaaS cluster API provider. This is the first project to realize the reference implementation for KaaS in SCS. And as you can see, there was not that much activity first. This were the first 5 months. I think it was 11 commits. And but later we had a bit more. And why the activity was that high in the last year has something to do with the next reference implementation, but you can see it later. I will compare them in some slides. And yeah, the KaaS cluster API provider was to provide a fully management toolbox inside of a VM. That means you need access to a SCS compliant IIS, and then you can just spin up, get a VM where all your tools are in, and then you can manage your Kubernetes clusters. But we didn't have that many adoptions, and I asked around why that is the case. And I think the biggest problem for most people was the script-based approach, which was quite complex and vulnerable because of many layers. So it's not just that you have shell script; it also has some Terraform stuff and something like this. And this was kind of hard to understand and also to maintain. And then we built many OpenStack tooling around it, which was kind of creating a artificial login, which is not in the sense of SCS. And also it was not really reusable for other providers. And with that, we removed one of the key features Cluster API provides to us. And then we had the last tender. This was the KaaS as a service integration. This is the VPO5. This was awarded also in the beginning of 2023 to SciSelf. And the work has been started in May. And why it was so late, I think correct. Because the thing is I think from the start of the tender to the award, there were around a half a year, and this is quite of the equivalent of 5 years in Kubernetes. And while the concept stayed the same, we needed to have a look on the new features and technologies which evolved in the last month. So we had a look together on how the solution would look like now, and one of these key features was the cluster class. This wasn't that new, but was really improved in that time. And on that cluster class, we had a lot design considerations, also with the other members of the container team, discussions and explanations. I think I ask Sven and Jannis probably every day the same questions to understand the technology. And then the idea of the cluster stacks came out and was developed. So now, how could we deal with two reference implementations now? Because we have the KaaS cluster API provider and the cluster stacks now. The idea was, because the cluster stacks needs to be developed, we used the old reference implementation to develop some things we need in the new reference implementation. And that you can, I wasn't able to shrink the graph, so what you see here is the same as in the bottom. And there you can see the activity was high because there we implemented all the technologies or the base technologies we wanted to use in the new reference implementation. And later it goes down because then we could implement it in the new reference implementation. So you can really good see in the commits where the development goes to. And also, since the OpenStack is still our primary IIS layer, we also developed the cluster stack provider OpenStack, which makes it possible to manage the images for the nodes we use inside the Kubernetes clusters on OpenStack, because, for example, the provider integration of cluster API is not able to do it itself. And a last slide for me. Cluster stacks need to define in some way. And to complete our reference implementation, we have predefined cluster stacks on GitHub. You can see it in the repository cluster stacks. And how to use them, you will find in the docs. And with that, I give over to Jannis. I think you can introduce yourself, and he will tell you a bit more about cluster stacks.
Thank you very much, Jan. So hi everyone, I'm Jannis. I'm one of the two founders of SciSelf, and we build the Kubernetes as a service integration. So I'm going to explain why we built this and why we think it's necessary. Because actually we kind of had the idea even a bit independent of SCS. So it was not an idea that we built for SCS, but we kind of were in the thought process of building something like this. And then just it happened to be at the same time as, we got to know STS. So why do we think cluster stacks are necessary? If we want to build a Kubernetes as a service solution, there are lots of things that we need to do. So you see there, you have the lifecycle of the cluster. Of course, you need to kind of provision your servers. You need to update them. But then at the same time, you have a lot of configuration on like multiple layers. And this configuration, you obviously need to build it. You need to test it. Like if it works, you can maybe package it, you can release it, and you can ship it to the users of your solution. There are lots of things that you need to do, and Cluster API does only one part of it, the cluster lifecycle. And the cluster lifecycle is a main part, so Cluster API is a great tool, but it's not kind of something that kind of covers everything that we need to take care of to have like a Kubernetes platform that is actually kind of well usable. And at the same time, this is kind of something we don't want to build something where we are all locked into like a very specific solution. So we wanted to build a framework. So what we did was we built a framework that facilitates all of the other parts that you see there, which are not in the scope of Cluster API. So what are cluster stacks? The first thing is, which goals do we want to achieve? And you can separate it into two components. The first one is the operations. So on the operations side, you need to kind of create your clusters. You need to be able to update them. You need to ship things to your users of the platform. And the whole process is supposed to be user-friendly. So like when you have a user, that person wants to update clusters easily, wants to create new clusters easily. So that's what we kind of consider as user-friendly. Same thing, it should be scalable. Like you don't want to have a platform and then you have like 5 clusters and that's all you can deal with. So we want the operations to be scalable. And at the same time, the whole thing should be reproducible so that you kind of don't create a mess of like different clusters, different like things you deal with. So you want something that always looks in a similar way. On the cluster side, the clusters are supposed to be ready to use. And they're like for the people who know a bit about Kubernetes and especially cluster API, that's not something that is so easy to achieve because if you create a cluster with cluster API, it's actually not usable directly. You need to install certain applications in your cluster and only after that you can actually use it. So we need to take care of certain applications, namely, for example, the Cloud Controller Manager, that are in the workload clusters. The second part is the clusters are supposed to be production ready. So of course we build a framework, so we cannot say these clusters built with that framework are production ready. Of course not. However, we can build a framework that allows production readiness. And one key thing actually among like for production readiness that kind of we consider to be very important are the node images, and that you can build your own custom node images and include them kind of in the whole configuration setup. Third thing is the clusters are supposed to be reliable in the sense that you are supposed to build or be able to build clusters with this framework that are actually reliable to your users. Okay, so the cluster stack framework, what does it consist of? On the left-hand side, I'm going to go a bit deeper into that in the next slide, are the cluster templates. So the cluster stack is a stack of components that a cluster consists of. So this is kind of what we call a cluster stack. And that's basically the idea, that you have lots of configuration of different layers also. You see 3 layers there. And all this configuration you bundle together, and then you need to do something with that. And that's what you see on the right-hand side. You have different tools. You have one tool that's the cluster stack operator. That's the main kind of tool to manage your operations from the kind of user perspective. So that's mainly the cluster stack operator is there so that you can ship cluster stacks to your users and that they are able to profit from them. You have a tool, a CLI tool that's called CS Kuttel, Cluster Stack Kuttel. That tool is mainly about building the cluster stacks. So that's for the people who actually build them, who test them. There you have a CLI tool that facilitates that process. And then, very important, and something that Jan also mentioned just now, are different provider integrations. Like actually they are on that slide, they are just kind of examples. Right now there are not so many provider integrations. However, you can have a cluster stack provider integration for each kind of cluster API provider integration that exists. So there's like a one-on-one relationship. Usually when you have a cluster API provider integration, you should also have a cluster stack provider integration, which is not as complicated. And then you can use it on your infrastructure. So it's kind of fully independent. The cluster stack operator, the cluster stack idea, the framework is fully independent of the infrastructure and can be used on all infrastructures. Okay, so that much about the overview of the framework. Let's have a closer look into the configuration. So there are 3 layers of the configuration. The bottom layer are the node images. As I said, we consider node images to be like a very important part for you to think about. So you should be able to build them on your own. The second layer is the Kubernetes configuration. So like everything related to kind of cluster API, to kubeadm, stuff like that. The third layer are the cluster add-ons, which is essentially very important applications in your cluster. So the cluster add-ons are important, as I said before, in order to first have a cluster that is ready to use. Like if you kind of give a user a cluster where you don't do anything on that layer, the user will not be able to use it directly and actually has to do some work before he can get started. So we don't want to have that. So we have the cluster add-ons where people, or like where we can kind of ship really important applications right into the cluster. And now let's think back about the cluster stack operator, because the cluster stack operator together with the provider integrations plays a really important role in kind of getting these different layers like ready to the user. And the provider integrations, they are responsible for the layer of the node images, because node images are usually something that is very dependent on your infrastructure. The provider integrations, for example, for OpenStack would take care of the node images for OpenStack. And that one actually exists. So that is one of the provider integrations that are already in use for the cluster stacks. The second layer of the Kubernetes configuration is something that has to go into the management cluster. So kind of for the people who don't know about Cluster API, the management cluster is kind of the platform where you can create your Kubernetes clusters. So you have the cluster, like the Kubernetes configuration, and that is what the cluster stack operator brings into the management cluster. The third component, the cluster add-ons, so the applications, have to go into each Kubernetes cluster, into each workload cluster that you create. So again, the cluster stack operator takes care of the fact that each cluster that a user creates automatically gets like certain applications installed. So in the end, I'm not going to show that today because there's not so much time. I don't even have the slides for that. So in the end, you can, as a user, have one object, one YAML object. You create that, and then based on that, you can do all the rest happens automatically. So you create this one object, you get like a cluster with the node images you specified before or you created before, with the applications into the cluster, and then like you can get started immediately. So it's just like one action, and then you get a ready made cluster based on this one cluster stack. And because the cluster stack bundles all of this configuration, you have the advantage that it looks exactly the same as the cluster you created before. Okay, so one last slide. It's the development cycle. I just wanted to stress it again. So the first step is you build your cluster stacks. For example, as a provider, as like whoever wants to use it internally, the Kubernetes experts, they will build it, they will test it, then they will release it. And then when it's released, it's somewhere out there and then like an OCI registry as GitHub release. And then people can use it. And kind of this shipment process to the users happens automatically also with the software. So you can ship it to as many customers as you want, as many users as you want, like without taking any manual action. Okay, that's it from my side. Thank you very much. We are going to do the same, more extended version of this together with Dination on Monday. So if you're interested, you can join in the open operations meeting.
Thank you very much for mentioning this.